In part 2, this is the mechanism of dehydration of alcohol. We can refer to the page 91. Okay, so according to the example 1, we need to focus of write the mechanism dehydration of the alcohol according to the formation of the major product form. So who is our major product according to the equation? Carbon-carbon double bond, so which is the alkene form from the alcohol. And before we start to draw the mechanism, we need to find out what is the specific type of the reaction. So according to equation, it's produced the water, so mean the type of reaction is elimination reaction. So according to the mechanism here, we have a several steps. First step, we are focused on the process protonation of alcohol. Second step, the formations of carbocation. Third step, rearrangement, if any, the main of the rearrangement to find out the stability of the carbon carbocation, and finalize the formation of alkene. So in the first step, this is considered protonation of alcohol, mean we need to find out where's the proton come out according to our reagent. So our reagent is the H2SO4 concentrated, and we can write the arrangement of atom in molecule in mechanism as a HOSO3H, and we just show the lone pair at the oxygen atom because oxygen atom establish two bonding pair and two lone pair. Okay, so we need to trace what happened to the process involved. Target kita adalah reaction occur must be at the hydroxyl group. So the process involved is elimination, mean target kita we need to covalently break between carbon and oxygen. So what happened? The lone pair at oxygen here will attack proton from our reagent because the first step is protonation. So we need to use full-headed arrow because the two electron lone pair oxygen will form covalently bond with the hydrogen, and the bonding between hydrogen and oxygen will disturb. So what happened? The two electrons share together directly given toward to this group of atom. So it can produce by using the reversible error. So we can produce CH3, CH, CH2, CH3, but differences arrangement of atom here at this part. O, we have a lone pair, the remaining bonding with H, and the new bonding pair form with the new hydrogen atom, mean the lone pair supply the electron to form the bonding pair with another hydrogen from the reagent, and our another product can be formed. What happened to the sulfuric acid? It can form O. Lone pair pada asalnya dia ada dua, so dia akan jadi 3, and then SO3H, and we calculate the formal charge for oxygen 6 minus 7, so this is overall charge is -1. So in the step number 2, we are focused on formation carbocation, where the location of carbocation must be formed. So the covalent bond, which is the cleavage occur between carbon and oxygen. So we can trace this oxygen, the formal charge is new, so the formal charge oxygen is become 6 minus 5, so this is become +1. So for right now, this oxygen less electron, so means it require electron. What happen to achieve a stability? 2 electron share between carbon will give directly toward the oxygen, means this step the cleavage occur, but this process occur must be in slow reaction because the stable product covalently bond outside, so we break down. So the final product can be formed after this stage, CH3, CH, CH2, CH3 plus a new side product form, which is molecule water form. So the second step already proved the process involved is elimination, and we can trace for second carbon will become charge positive. So means this is a carbocation, and what is the classification for this carbocation? So we are trace this C plus attach 1 to alkyl group, mean this is secondary carbocation. So we need to trace is that the step number 3 occur. Okay, so now we need to trace the step number 3 occur or not. So for right now, we already form the secondary carbocation. Target rearrangement is that we can form tertiary carbon carbocation from arrangement of atom. So when we are traced, if hydrogen is moved, so it's still same secondary carbocation, meaning rearrangement cannot be occur. So means the step number 3 not exist in this reaction. So but before we start to proceed to the step number 4, we recall it back step number 1. So remember we have a charge positive at this oxygen because oxygen here is less of the electron. So now we focus to the step number 4. Okay, in step number 4, which is the formation of alkene. So kita nak cari alkene. How? The first step, we already remove the OH. So for right now, we need to eliminate hydrogen. Where's the hydrogen? The hydrogen must be eliminate carbon that neighboring to the carbon carbocation. Means despite. Okay, so target dia adalah major product. So therefore, we can eliminate hydrogen from the carbon number 2. But this reaction must be take place between what? Between OSO3 H minus tadi. So from where? From the reagent concentrated sulfuric acid after proton is accept to form a bonding pair. Proton is donate to form a bonding pair to form the which is the step 1, protonation of alcohol. So what happened here? Okay, from lone pair the oxygen here, so it must be form sulfuric acid again because sulfuric acid now as a catalyst. So this lone pair will attack hydrogen that covalently bond toward to the carbon neighboring to the C+. So at the same time, the covalently bond have a 2 electron will stabilize between both carbon atom, which is its own carbon, and carbon carbocation to form the alkene group. So the product can be formed CH3C double bond CH3 plus H bonding again with O SO3H means we produce acidic again because acidic now as a catalyst. Okay, second possibility maybe we can eliminate hydrogen from carbon number 1. So what happened? Lone pair here will attack a proton, which is we remove the hydrogen without electron. So the covalently bond have a 2 electron together will stabilize their own carbon number 1 and its carbon carbocation to form the new product we can call carbon double bond CH2. See, this is we have H, the rest atom are same and the side product still same, sulfuric acid form again. But according to the question guide, you must to show the mechanism, the formation of the major product. So this is our first possibility and this our second possibility. So from this step, you must be differentiate which one the major product. So how we can classify the major product from the product form. According to the safe rule, your carbon-carbon double bond must be have the highly substituted group. So means the carbon here have 1, 2. So it have 2 times of alkyl group. Second possibility, carbon-carbon double bond here only attach 1 group of alkyl. So means it just have 1 alkyl group. So according to the safe rule, the major product should be the most stable alkene. So which one? The highly substituted group. So the first condition we can label as a major product. And the second part here is a minor product. So remember, in our exam, you must be answered according to the question. If question given to you, show the mechanism of the major product, just show this mechanism for major. So no need to show the minor. So this minor are just to show differences between how the process involved between them.